Hi guys, welcome to lecture number 4. In this lecture, we'll continue discussing a little more about matrices. Remember, we said at the beginning of the course that MATLAB actually stands for Matrix Lab. There's a lot of manipulation about matrices in MATLAB, and so that's the one of the major focuses on the course, because the more you know how to manipulate matrices, the easier it will be to do all the more interesting things with them. And so actually along the whole course, we're going to be using matrices, introducing a few more features, but I want to focus on some of the things we can do with matrices, more so with multidimensional. In the past couple of lectures, we really looked more into sort of one-dimensional applications and not so much about multidimensional. And so that's what we'll do today. I also want to finish the lecture by looking at complex numbers, how to manipulate complex numbers, and how to use them in MATLAB. So let's get started. And I'm going to share my screen here. All right. So I'm going to start by creating what is called a magic matrix. You've probably seen this matrix before in MATLAB or some other place. MATLAB uses it a lot in order to manipulate examples, okay? And so the magic matrix is nothing more than a square matrix with a feature that when you look at all the numbers along any row or any column or any diagonal, the numbers add up to the same value. So the way you create a magic matrix is simple. You just use the magic command. So I'm going to create a matrix A, and I'm going to use the magic command, and I'm going to give it a 5 by 5, and you just use that one number to indicate the number of rows and columns. In this case, I'm going to create a 5 by 5 matrix with the numbers, and so the idea is that any number that you add up along the row or column or diagonal is going to add up to the same value. And one quick way to check that out is if I use the sum function, the sum function by default is going to add up values along the columns. So as you can see, it's giving me the values add up that you can get when you add up every single number along the columns. If I do a transpose of that, it's going to give me the addition of all the numbers along the rows. So this again shows that all the rows, all the columns add up to the same number. If you remember, if I want to look at the diagonal elements of a matrix, I can use this command. And so that shows me the diagonal elements, right? You can see 17, 5, 13, 21, 9, and so forth. So if I want to add up the numbers along the diagonal, I can also use that. And as you can see, the numbers along the diagonal also add up to 65. So that's why it's called a magic matrix. But that's not the purpose of this lecture. I just want to show you what it means. And, it's used so much in MATLAB that I wanted to show you what it really means. But anyhow, let me bring back the matrix I created, and let's just use some manipulations on how to extract information from that matrix. So for instance, if I want to look at all the elements on the third row for this matrix, I can use this simple command. And what that does is it extracts just that column, right? And what it's actually saying is look at all the elements along any row, right? All the rows, actually, all the rows of the matrix, but extract the information on the third column, and that's what you see here. If you do the reverse, right, then looking at the columns instead, then I extract, the elements from the row. So what that means is that, again, look at the third row, right? This number 3 means look at the third row, and as you go along the third row, because that's the one you're focusing on, just extract all the numbers you see. And that's what it does right here, right? So that's one way of extracting information. If I want, for example, look at all the elements in the second through fifth column of A, Right? So I can do that by looking at all the elements in the second through fifth column, and do that. And as you can see, it gives me all the elements except the first column, right? If you look at the original matrix, right, has this column in it. But with this command, right, I skip that column. And so I'm just looking at all of the elements in this section, right? So things like that you can do. If I do a like that, it's going to show me all the elements on the column stacked from first to last. In other words, it's going to show me this is the first element, and it's going to just show me following this path along the each of the column until you see the last element. So as you can see, it shows all the elements as one single column. And in fact, the matrices in MATLAB, matrices elements in MATLAB are stored as a single list. They're stored just like a single line. In other words, it continues from the first element in the matrix to the last element in the matrix in this order. So this will be the first element in the matrix, and it just follows this order here. It goes from here to here to here, sort of like a snake, right? Till it gets to the 9 here, right? That's the way matrix elements are stored in MATLAB, okay? Now, that's not the way we usually look at matrices, right? But there's another way of getting elements, for example. So if you look at the IA matrix again, the original matrix, I know that if I want to get the element, the last element on the fifth column, right? And then this word, in other words, the first row, fifth column element is going to be 15, right? Same way, if I want to look at the element on the second row in the fourth column, I'm going to get 14, right here. Okay. So in other words, with this subscript, with this index, I can get to any information along the matrix. But going back to that idea I told you about how MATLAB stores matrix information, I can also extract the same information if I look at this as a single list. So if you start from here, this will be element 1 through 5th. And as you go back to the top, this will be element 6, right? So this will be element 10, 11, 15, 16, and so forth, right? So if you want to go to, for example, this element here will be 17, right? Because you had 5, 10, 15, 16, 17. So if I do A17, I'm extracting the same number, 14, right? So you get the idea. It goes like a snake, right, around. So if I want to go, so this will be 20, 21, 22, 23. If I want to look at element 23, you get an idea what you're going to get, right? Which is the number 22 here. All right. Okay. So let's clear this up. Now I'm going to look at, I have a matrix here that I created before, a 4x4 matrix. And one of the things I want to do now is I want to extract a portion of that matrix, right? So let's say I want to create a matrix E, and that matrix will have a portion of the matrix B in it, and I can select whatever I want, right? But in this case, I'm going to go. I'm selecting from B, right? So I'm going to go from row 2 to 3 and column 1 to 3. Okay. And what will that do? As you can see, is selecting just this portion of the matrix, right? Starting from 16, 3, 7, and 8, 4, and 9, right? This portion and that portion, right? Because that's what I'm extracting, right? The second row through the third column, right? And the first row through the third column. That's all I want. So I'm extracting that information from matrix B. So that's one sort of manipulation you can do. All right. So in MATLAB, you can also define a matrix by typing, as you know, and a list of numbers enclosing square brackets, or you can separate number by spaces or commas, right? So if I do, as you know, if I do I'm going to define another matrix here. I'm going to get rid of, well, I could still use the same one. But if I do, for example, let's do B with this elements here. Let's go to B. And I'm going to define it as elements 1.5, comma 3.1, right? So 1.05, 1.5, it doesn't matter in this example. So obviously what that gives me is just one row with two columns, right? I can ignore the comma, and as long as I have a space, right? You know, I get the same thing. I can also, let's say I'm going to change that matrix B, and I'm going to select different rows and different columns. I'm going to go 1, 5, 6, and I can go for the next row 5 to 8. Oops, it spaces to 8, and one more, 6, 8, 7, and then I close that with the brackets, right? 6, 8, 7. Of course, that generates a 3 by 3 matrix. I can do the same thing if I wanted to without the semicolons. And I'm going to start with the first row here. And what I can do is I simply go to the next line and type in the numbers 5 to 8. And I go to the next line and I type 6, 8, 7, and I close the brackets, right? So, you know, it's another way of entering the same information in a matrix, and I'm avoiding the use of semicolons, right? I'm just, you know, doing it that way. Sometimes when you write a program, doing it this way may look better when you look at the code or when you look at your the information you're presenting in a matrix than something like this, right? So it's another way of doing it, and the result, as you can see, it is the same. All right. So if you also have a very large set of numbers, you can use a set of 3 periods to indicate that a row is continuing on the next line. So if I have, let's do again the matrix B equals, and I'm going to put just numbers in it, random numbers, 2, 3, 4, 5, 6, 7. And if I do the 3 periods, okay, oops, one extra, that just indicates that the line continues. Sorry about that. That just indicates that the line continues, but I need commas in it. Sorry about that. Let's do that again. So if I have 1 comma, 2 comma, 3 comma, 4 comma, 5, do the 3 period points, I continue now, go 6 comma 7, and I'm going to close it with the brackets. And again, you know, that creates what I wanted to create, this row vector, but showing that you can use the 3 periods to indicate that this continues on the next line. Okay, and you can do it for any number of lines that you want. Okay. Okay. We can also define a matrix in terms of another matrix that has already been defined. So let's bring back the last B that I have. This is the matrix that I have. And now I want to create another matrix, right? And the new matrix that I want is going to add or concatenate, if you want, the information that I have inside this bracket. So if I want to have a new matrix S, and I have the element 5 in that matrix, okay, but now I'm going to follow that by B, which is the matrix I have just previously defined. Now S is going to add up this value 5 to it, right, to the matrix B. You can do it for any number, right? If I want to create a matrix that has double the information that I had original in B, you can see I double that information, right, with B, okay? So that's how you can do matrices from another matrix or extend a matrix by defining new elements. In this case, we expanded the matrix S by combining the values of the two matrices together, right? And again, you can expand this for any number. You can do, let's see, I still have the C in it. Yeah. So if I now add C to that, then you see how I keep expanding that matrix from other matrices. I can also define matrices in terms of another matrix that has already been defined like this, or I can extend the matrix by defining new elements. For example, let me create a matrix. Let me bring back a matrix S, but this time I want to have less elements than the last iteration I had. So I'm going to have A comma the original B, right? And now I have just those 8 elements, right? Starting with number 8. Then now I want to add, I want to extend the matrix, right? So the matrix has 8 values, right? And then if I do something like this, let's say I want to add 12, and I want to put the number 12 or 10, whatever, in that location, right? See, what happened was that the original matrix, right, has 8 elements, right? But I want to put a new element in location 12. Well, location 12 doesn't exist. And what the command does is that it puts zeros in between until it reaches the 12th element. So the original matrix, or vector in this case, has 8 elements, right? And I want to add an element to, or a number to element 12, but element 12 doesn't exist. And so since I only have 8, he puts zeros in between until it sees the last element in it. So that's another way to extend a matrix by adding elements. All right. So let's look now at some ways of extracting information, like I said before. Let's go back and bring back the A matrix, right? So if I want to, again, look at all the rows in column 1, all the rows in column 1, this is one way of getting that, right? If you want to look at all the rows, row 1 and all the columns, you just do the reverse. If I want to extract the 2 bottom rows of the matrix, if I want to extract just the 2 bottom rows of the matrix, then I can just use this information, just like I did just now previously, right? And that's again the last 2 rows for the matrix. Okay. And let's see. Oh, this was using matrix M, which I have M as this. So you can see that those are the last 2 the last two rows, right? Okay, so you can practice with this and look at, how can you extract more information just like that, right? All right. If we look at another command that is called the mesh grid, what the mesh grid command takes the two input vectors and create two two-dimensional matrices. Each of the matrices has the same number of rows and columns, and the number of columns is determined by the number of elements in the first input vector. And the number of rows is determined by the number of elements in the second input vector. So it sounds more complicated than it is. And if you type help mesh grid, you can see, that's basically the information I just told you of what it does. Okay, it gives you a two-dimensional grid, and it sounds more complicated than it is, but I'm going to show you with an example what this does. So I'm going to define two vectors. Let me define vector x as with elements 1, 2, and 3. All right. Sorry, let me clear that up. I meant capital X. All right, that's what I wanted. So we have that matrix X, and now I'm going to define a matrix Y. The numbers really don't matter. I just want to use that information to show you how to use the matrix command.